Тимове трябва да е, да. Наш глад е той.
We're going to start in about 5 minutes, okay?
But if we need to extend the cover and we stay up late to discuss, let's try to figure this out. I think this is making it or falls outward. Let's figure the schedule out, and if we need to extend our coverage to later hours, try to accommodate that.
Grazie,
Dobro večer. Hello, everybody. Unfortunately, that's the extent of my Bulgarian in the short time I had to prepare. I'm sorry. I'm going to speak in English from this point forward, if that's okay. My name is Etienne. I am a staff UI engineer here at VMware. I actually work from home in New York, but I'm visiting this week to meet colleagues because I work closely with a lot of the engineers here in the Sueur office. It's been an exciting trip so far, very busy. I will have a bit of time next week to do some travel around and see your beautiful country. So tonight I'm going to talk to you about VMware's transition to a cloud services company and some of the challenges that we have in that process. VMware has traditionally been an enterprise software company that delivers software to customers who install it on their servers in their own data center. And that has worked very well for us for many years. With the advent of public clouds and the ease with which you can use a public cloud and expand your capacity, there's an obvious reason for VMware to look at how we can provide access to those public clouds for our customers and add value on top of what those public clouds offer. So I would like to give a brief overview of our software stack, which is called vSphere. I'll talk about how we delivered that software in the past and how we intend to and are currently delivering the software now and into the future. I'll give you an overview of VMware Cloud Services, which is our product portfolio for cloud services. And specifically, I'm going to focus on VMware Cloud on AWS, which I've been involved in on the UI side. And there's some pretty cool stuff that I can show you with how we're bringing up the vSphere stack in AWS. And then there's going to be plenty of time for questions. I'm happy to answer any questions that you have. All of the stuff that I'm about to show you is obviously public. It's not going to be any confidential stuff for obvious reasons. So, who am I? I guess I told you I'm a staff UI engineer. I've been with VMware for about 6.5 years. I originally started working on our Type 1 hypervisor, which is ESXi. This is an operating system. It's quite similar to Linux. It's got like a command line interface. It had a basic UI that you can see in the background there, the gray and the yellow. That's what you get on the screen when you install ESXi. You can't do much from there. You can't run a virtual machine from there. You can do basic system administration. The next screenshot, which you can see with the blue surround, is actually the first UI that I became involved in. And it is the host management interface, which it's a web application, and it runs embedded within ESXi hypervisor, and then you just visit the IP address of the host in your browser and you get that UI. So that's the second project I became involved in. And then the last two are screenshots from VMware Cloud on AWS and the VMware Cloud Services console. So that's who I am. I started off working in operating systems and in the lower levels and quickly realized that UI was what I loved. And so for the last 4 or so years, I've been working on the UIs. So I am a UI engineer, therefore I love Angular and Chrome. But the world that we live in is not that perfect. And sometimes I might get a message from my manager that says, there's a bug in production. And I'm going to say, this is midnight New York time. What's the issue? Sorry, it says 9:55 because the screenshots this morning in Bulgaria were different time zones. Users can't log in Internet Explorer. Great. So I'm on it, right? I'm going to get up and start looking at this issue. This doesn't happen very often, by the way. That's why we have offices all over the world, so that we have people online in different time zones. So it's an Internet Explorer bug. It's my worst nightmare, right? I'm trying to reproduce this bug in a browser that's 15 years old, but we still have customers who use Internet Explorer 11. Luckily, we don't have to go back any further than that. How am I going to reproduce the bug? I am a Mac user, I run Mac OS, and virtual machines to the rescue. So I'm going to boot up my Windows 8 VM, and Microsoft has nicely provided an image, a virtual machine image that I can freely download. I just type in Windows VM download into Google, and the first match is on the developer.microsoft.com site, and I download the virtual machine for VMware's platform, and then 5 minutes later, if I have a fast internet connection, I can bring up Windows 8.1 with IE 11 and reproduce my bug. I don't have to deal with a second laptop or a desktop system that has Windows on it for the one bug that I get every year in Internet Explorer. Virtual machines solve this problem for me. So what I talked about there is what we call desktop virtualization. In comparison to ESXi, which I was talking about before, desktop virtualization uses a type 2 hypervisor, which means that the system runs on top of another operating system like macOS or Windows. And the two products that VMware has in this space are Workstation, which is for Windows and Linux, and Fusion, which is for macOS. So the screenshot that you saw before was Fusion running Windows 8.1 on my Mac. So that allows me to load up my UI in Internet Explorer and figure out what's going on, and presumably it's a trivial issue to fix, and I can submit the code and get the issue fixed and into the pipeline. But that's not the enterprise. So the biggest group of customers, or at least the customers where we get most of our income from or revenue from, is in the enterprise. And this is actually a much more interesting space to work in my opinion, because the types of challenges that we have in the enterprise space are much more complex and interesting to solve than what exists on a person's laptop. So a type 1 hypervisor like ESXi runs on bare metal, which means it's the main operating system that runs on the physical hardware. And as I said, the product that we have, which is called ESXi, is this type 1 hypervisor. But enterprise is more than just one server, right? We might have some customers who have one server in an office. This is a small business. They can still use ESXi, and they can use the host management UI that I talked about before, and they might have 15 virtual machines, and it works just fine. However, most of our customers are bigger than that, and they have tens, hundreds, possibly even thousands of servers running ESXi. And on top of those servers, we have thousands of virtual machines, and it quickly becomes a challenge to manage a virtual infrastructure of that scale. So the product that we have, which helps customers solve those problems, is called vCenter Server. And I'm going to show you a bit about vCenter Server later on. But there are other challenges as well. Storage. Where are we going to put all of those virtual machine disks? And how are we going to allow virtual machines to share storage with each other? And storage also has other implications in the management of a large virtual infrastructure, mostly around capacity management and workload migration to manage the load across a large cluster of servers. Historically, shared storage in a data center was solved with a huge, expensive network-attached storage appliance, which could cost hundreds of thousands of dollars, have thousands of spinning disks, and a huge maintenance contract, and suck up a lot of power. And this was something that didn't give you any compute, right? Nothing other than storage. And modern day infrastructure, which is what we call hyper-converged infrastructure, is where you don't have this massive network-attached storage system anymore, but you have storage that already existed on the servers that you were running, right? You had thousands of servers. They have to have their operating system somewhere, so usually it's a flash device or a disk or some number of disks running in the server. We can make use of that storage and virtualize the storage, collecting all of that storage together from different servers, and present it as a single storage device that can be shared across a cluster of servers. So the product that VMware developed for this is called vSAN, or Virtual Storage Area Network. And basically it is aggregating the disk storage and flash storage from a number of different servers in the cluster and presenting it as a single volume that can be shared across all of those servers. Networking, right? Thousands of VMs means thousands of IP addresses. And if you've ever managed an IT infrastructure, maybe you have, maybe you haven't, but IP address management quickly becomes a nightmare. Some people want static IPs, some people don't care. Every day you'll get a request for a host name that is matched to a static IP, and managing all that infrastructure is an absolute nightmare, or has been in the past. VMware has, over the past few years, started to virtualize the network. And modern day network virtualization simplifies the management and also improves security across a virtual infrastructure. And the product that we have in our stack, which helps with that, is called NSX. It's a fairly new product. Customers are starting to get onto it, and it simplifies all of the management of the networking in a large virtual infrastructure. So putting all of those together, we have the stack that we call vSphere. So I mentioned before that the traditional delivery model for this stack was what we call on-premises, and it might not actually be in the bottom of the customer's building, but they'll have a data center that they're renting space from somewhere, and they'll buy servers and deploy them into that data center, and then they'll be responsible for purchasing a VMware license and installing the vSphere stack themselves on those servers, and they'll manage the stack themselves. They'll do the installations, they'll do the upgrades, they'll manage the patching. We delivered the software to them literally in a box. We have a term that we call in-box, and that literally means a DVD in a box. That was a long time ago. Nowadays, customers can download an ISO image from VMware.com, and they can mount it using some ILO or management controller and install it that way. So we don't deliver physical media to customers anymore, but you get the idea. These days it's changing. Support is usually provided after issues are identified. If a customer hits an issue with the virtual machine performance, they'll come to us for help, or I guess they'll try and solve the problem themselves first. But the support model is usually customer reaches out to VMware and we try to solve the problem with them. And the last bullet point here is the critical one, because the addition of new resources takes weeks to months in a data center. And you can imagine you're a large company, you want to run your data center capacity sort of as close to the maximum as possible, so you're not wasting resources. Servers are expensive. Running them costs power, both to run the server itself and to cool the data center. Firstly, identifying a capacity issue. That's something that we help with because we have monitoring and alarms that can tell you when your servers are reaching a load level that means you need to do something. You've got to spec and order the new servers. This evolution of a data center capacity means you will have old servers and new servers in a complete range of age. So you're managing hardware from maybe different vendors, different ages. You're managing failures yourself. You've got to take delivery of the new servers, provision them in the data center, install the software. Then you've got the opportunity to do migrations to level out the load. This is costly. It's a capital expenditure which depreciates significantly over time, right? The Mac laptop on the desk here is 4 years old. I couldn't even sell it. Nobody would want it. And the operational cost as well, right? The power and the air conditioning. So the last few years have seen public cloud become a very reliable source of compute capacity. and storage. Usually provisioning a new server in AWS or some other public cloud takes minutes. So gone are the days where you have to order the server yourself and wait for it to physically get delivered. Software installation is often as simple as a button click. Right? I have a hosting provider and I can deploy a MySQL instance or a MariaDB instance by clicking a button. And you can do this in AWS as well. The capital cost for me is zero. I didn't pay for the server. And the last bullet point is where it sort of gets interesting, because the operational cost can be huge. If you're not watching, running an AWS instance can cost you thousands of dollars. And enterprises who have large workloads in public cloud often get what's known as bill shock, where a developer has deployed 10 instances in AWS and they're running compute-intensive workloads and they forget about them for a month, and then suddenly you get a bill for thousands of dollars. So managing public cloud infrastructure for enterprises is really difficult, and this is where VMware is looking to provide value. All of those points. So VMware customers really want to take advantage of the public cloud because of the reasons I just described. It's easy, it's quick. So in the last couple of years, VMware and AWS have gotten together to give our customers access to AWS compute infrastructure. So AWS has data centers all over the world. Customers in the US to run a data center in Europe is a huge burden, right? Either you open an office in Europe, which is fine, but you still have to manage that data center. Moving data between those data centers, if you need to do workload migration, is expensive. Giving our customers access to AWS is a huge benefit. Not only just getting access to different regions, but the ability to expand your capacity into the public cloud at the click of a button is massive. So the collaboration that we have with AWS is all about making VMware's software available in AWS data centers. So our customers like using our software. As a UI engineer working for VMware, it's my goal in life to make our UIs as nice and easy to use as possible, and customers like using them. So this is what we've been building up over the last couple of years. It's the ability to continue to have your data center on premise, and you can manage that yourself, because there's some requirement to maybe have the data close to the people who need to use it, or there's some workloads that you just don't want to have in the public cloud because of data privacy issues, for example. So you want to have your on-premise data center still, but you want to get the benefits of public cloud in that if you run out of space in your on-premise data center and you really need another server, you don't have to wait months to order a new one. You don't have to pay for the server. VMware Cloud on AWS allows you to bring up the vSphere stack in AWS in the region of your choice at the click of a button. And using existing vSphere technologies like vMotion, which allows you to move virtual machines from one server to another with zero downtime. You can do that between your on-premise data center and your SDDC or your data center running in AWS. And the whole vSphere stack is what makes this possible. So you can see that the IP address of the virtual machine that we're moving to the cloud has not changed, and NSX allows this. And the storage can be vMotioned as well. That takes time, of course, but vSAN allows you to do storage migration. If your data set is so large that doing a migration over the wire is going to be ridiculously long, then AWS has a cool feature where you can basically get them to send you a disk. You connect that disk to the server, and then you dump the virtual machine's data onto the disk, and then you put the disk in the courier or the post and send it to AWS. They'll connect it to the server in the AWS data center for you, and now your data has gotten into the AWS data center without paying for the traffic over the internet and without the long time. So bringing up the vSphere stack in AWS means customers can use the same software that they've been using for years. They can use the features of the vSphere stack to easily move things back and forth. And this is a really compelling reason for customers to use this. So we've talked about what VMware Cloud on AWS is. It's a different model for delivering our software. In the past, when I joined VMware, delivering a new version of ESXi, which comes in the vSphere stack, was over a year. So we would work on vSphere 6.5 starting in January of one year, and then the February of the following year, we would finally say, okay, we're ready. Here you go. And customers would take it and install it themselves. We would test the hell out of it, make sure that we had everything working. And we're a software company, so there are going to be bugs. And for me to fix a bug in a piece of software that I delivered to a customer on premise is an absolute nightmare. So not only do you have the long delivery cycle because you have to do so much testing, but even with all that testing, there are going to be bugs. And to fix those bugs in a customer's data center is a nightmare. So customers are expecting those bugs to be fixed, right? They find a bug, which is terrible, right? A customer should not find the bug. But when they do, we need to fix it and get the fix to them. So they're expecting the bug to be fixed tomorrow. And we simply can't do that unless everybody gets up and starts running around with their heads dangling like chickens, right? That becomes a complete nightmare. So, as I said before, customers who are wanting to expand into the cloud are going to pay VMware to get access to physical servers in Amazon's data centers running the vSphere stack that they're familiar with. But the difference is that in this case, VMware will manage the entire life cycle of that part of the stack. So if we find a bug, we will fix the bug and patch the AWS data center with the fix, and we can decide how urgent that is and how much effort we want to put into fixing it tomorrow. If it's a critical bug, we will fix it tomorrow, and that customer will be much happier than if we had to take a few weeks to fix the issue, test it, and give them the new CD that they have to upgrade to. Not only are we introducing a bug for them, but we're saying, okay, here's the fix, you go and install it. So with VMware Cloud Services, the UIs that I've been working on over the last few years are what we call our console UIs. And these are the UIs that customers use to, for example, deploy a new AWS SDDC instance, or get access to other services that we provide in the cloud services ecosystem. The architecture of the console UIs is a microservice architecture. It's based on Java backend, mostly using Spring. We did have a mixture of different Java frameworks before, but we're all sort of moving towards using Spring. The way that we're running this cluster in AWS actually is using Kubernetes, and this is a much more reliable way for us to manage a cluster of microservices. We have different teams working on different parts of the system. They're all working in parallel, and we're following a CI/CD agile process. We run sprints, and when you merge code, it goes into the pipeline, and then the following week we push into production. So this is how we're managing the console UIs. They're all written in Angular, not AngularJS, sorry. And unless there's an urgent issue that needs to be fixed tomorrow, we will do a production push on a regular weekly cadence. Over the 6 years that I've been at VMware, the way that developers, the responsibility of developers has become a lot more focused. Previously, when I joined, we would have a QE team. So I would write the code and I would test the code. And then a QE team would pick it up and start testing it. And when the software goes out the door to the customer, there was even a different team that was responsible for that code now. And I would move on to the next feature. And this has changed over the last 6 years as we sort of realized that ultimately developers are responsible for the code they write. And as much as it increases my stress a little bit, ultimately it drives us towards higher quality software, because I know that if I introduce a bug and a customer finds it, I'm going to have to fix it. So when I'm writing software now, I'm thinking about that and making sure that the testing that I do is extremely thorough, and if I don't, I'm going to get a page in the middle of the night maybe. So our developers are responsible for the quality of the code. So this is what I want. I want to be able, I mean, I'm going to introduce a bug at some point, right? It happens. But the critical thing is, how fast can I fix that bug? If I find the bug myself before a customer does, can I get the fix into production before anybody even notices? That would be ideal. But different parts of the stack have different cycle lengths, right? Even though we've made vast improvements to the way that we develop the vSphere stack, we used to have a cycle which was over a year. We've reduced it down to 3 months, which is a huge reduction in time it takes to build and test the stack. But it means that if I find a bug in that part of the stack, it's still going to take a while to get it to customers, unless there's a really high urgency to get that fix in, and we do a special patch for it. But in terms of getting features out to customers, which is really why I work, right? I want to make improvements to our UI. I want to introduce new things that are going to help customers on a day-to-day basis. I want to move to new technologies. I don't want to have to keep supporting an old AngularJS app for 5 years, which is our on-premise support cycle. So if we deliver software to customers' on-premise environment, we have to support that software for at least 5 years. And that means the UI that I wrote in AngularJS in 2015, I have to keep writing AngularJS until at least 2020, which I really, really don't want to do. So there's a huge impetus for us as developers to improve the way we develop software and push ourselves to this SaaS delivery model where we manage the deployment, we manage how frequently we do upgrades, these sorts of things. So going from a piece of software that I have to work on for a year and then deliver to the customer, to a UI that I can work on and then I know that it's going to get into production the following week is just amazing. And I wish all of our software could be like that. As I was saying, the vSphere stack doesn't push weekly, right? It's still a huge chunk of software, and building new features and changing the UI technologies requires a lot of testing. And so the vSphere stack pushes feature releases quarterly, and for security patches and minor bug issues, we push patches in monthly. So I wanted to stop talking there and spend a bit of time showing you all the vSphere stack. But before I do that, I want to announce that there are going to be two tickets to the Java 2-day conference. So who here is a Java engineer? 1, 2, 3, 4, 5, 6, 7, 8. What about UI engineer? 1, 2, 3, 4, 5. So we've got a mixture. So sorry UI guys, the Java conference is probably not for you. But if you're interested in a Java conference, who here is not an engineer? I see a few hands. So the first ticket is going to go to the person who can guess how many AWS data centers or regions do we have in VMware Cloud on AWS. I will tell you the answer later on. The second ticket is going to be a draw. So we'll do that later on as well. So let's take a look at some UIs. So this is the host client UI that I was talking about before. It looks quite different to the UIs that I'm going to show you later. This is a UI that we started 2 or 3 years ago, I think, and it's unfortunately still based on AngularJS. So we're looking for people to help move us to the new version. By the way, we're looking to hire UI engineers and Java engineers. So if you want to help us move to the new technology stack, come talk to us a bit later. So what this is the UI for ESXi. That's the hypervisor operating system that I was talking about before. And this is actually running on a server in California, and it's running all of the virtual machines that I use to test various different projects that I'm involved in. So there's a bunch of virtual machines in here. But let's create a new virtual machine. So I have a virtual machine that's a bit of fun. I'm going to choose to deploy a virtual machine from what's known as an OVF template. This is basically a pre-configured virtual machine. I don't have to choose how many CPUs, I don't have to choose how much memory. It's just a file that contains a disk and a configuration. Anybody guess what it's going to be? So I'm going to choose which data store. So that's essentially the storage volume that this server has access to. There's a bunch of NFS storage volumes, but I don't want to stick it there. So I'm going to choose the VMFS volume, which is local to the machine. I'm going to power it on. And let's see how long it's going to take to upload. The image is about 100 megabytes, so that was fast. All right. So it powered on. So this is an HTML5 JavaScript AngularJS application. It's got no plugins. I was able to get that virtual machine up and running and a console inside the browser in 30 seconds. And now I can play Doom. So this is running on the server in California. And it's quite playable. So that was fun. That was a really fun project to work on, by the way. All of the interesting technology that allows me to bring up a virtual machine's console inside the browser without plugins. This is all JavaScript, right? So this library that I'm using to show the screen is a VNC implementation in JavaScript using a WebSocket connection that obviously is browser to California, and I'm able to play Doom in real time at low resolution, but in real time. And that was DOS, by the way. So this is one of the UIs that I was involved in and was a really fun project. But let's look at something that's a little bit more interesting from the enterprise point of view. So I talked about VMware Cloud Services and how we are now allowing customers to bring up the vSphere stack in AWS. So I'm going to head over to the console, which is console.cloud.vmware.com. This is the UI that I'm currently working on. And it's more recently, it was a greenfield app that we started more recently, so it's currently on Angular 6, which is much nicer to work with. So here you're seeing the console, and the cards at the top are a bunch of different services that VMware offers, and these are the ones that I'm paying for. So you can see here that I am paying for VMware Cloud on AWS, Cost Insight, Hybrid Cloud Extension, and Log Intelligence. And we have a number of other different services that are available in various different stages of development. Some are in beta, some of them you have to ask to be invited to use. So it's not like you can just say, yes, I want to use that one. You have to request access. But let's go and take a look at VMware Cloud on AWS. So this is a UI that is managed and built by a completely different team. So the Cloud Console is, there's a team here in Sueur working on that, several teams actually. And then there's a big team in Israel working on the Cloud Console. The VMC, or VMware Cloud on AWS console, is being built by a team in California. And so we're spread all over the place. So what you're seeing here is that VMware Cloud on AWS is experiencing an outage. That's not great. So let's go and see what's going on. It says we're experiencing a capacity issue in the US East region. So seems like if I wanted to bring up a new vSphere instance in the US East region, it might fail because there's no servers left. So this is something that Amazon has to fix. It's not really a bug, so I'm just going to ignore that for now. I've already got an SDDC here, and this one I deployed in US West because there's plenty of capacity there. Unfortunately, deploying this SDDC was not minutes. It was a couple of hours. So I can't deploy one for you now and show you how that deployment process works in the real case. But because I'm a diligent developer and I want to test my stuff, we implemented a mock SDDC, which we call Zero Cloud. And I can deploy a Zero Cloud pretty quickly. So I'm going to choose Zero Cloud instead of AWS. I don't need to connect an AWS account, so I'm just going to skip that for now. And I don't need to specify the networking management subnet. It's an optional input. And then I click deploy. So it says it's going to take 114 minutes. That's the real case, but it will go much faster because this is the mock. So this mock allows us to test most of the UI without actually using a server, firstly, because they're expensive. The servers that we actually bring up in AWS are huge. So the capacity of that server is a 2-socket system with 36 cores and 512 gigs of RAM. So you can imagine how much that costs. Luckily, my Zero Cloud did not consume a server. But the Zero Cloud is pretty much a fully functioning SDDC, and I can browse to it, I can look at all of its network configuration, I can create firewall rules to allow me to get access to it. The only thing I can't actually do is open up the real UI that allows you to create virtual machines. So I can test this pretty much to its entirety without using any physical resources or costing the company any money, and fast. But that's not that interesting, so I'm going to take you back to the real one, which I deployed last night. This is a real one, and it's got some configuration that I need to do because it's a brand new stack. So by default, it's secure. I can't get access to it. The firewall rules are not set up to allow access. Remember, this is on the public internet. So if I look at the settings page, the vSphere client, which is the UI I'm going to take you to in a second, has a domain name which I can resolve publicly, right? So by default, we don't open up firewall rules to allow access. So let's go do that. So I'm going to create a firewall rule on the management gateway. I'm going to call it vCenter. The source IP I'm going to say is any. I don't really care at this point which IP address I'm going to allow access to. I want to give access to ESXi, and I need to allow HTTPS. So let me create that firewall rule firstly. So that was done. All right, so now I can open up the vCenter UI. So by default, when we deploy a new stack, we set up an administration account and we choose a random password, and you can go and change that later. So let's copy that to the clipboard and open up the vSphere UI. So this UI has a huge team here in Sofia. They've been working on this UI for years and years, and recently, I guess within the last couple of years, we embarked on a huge project to take this from our old Flex and Flash UI, which we built up over a period of years, and evolved it to initially AngularJS and now Angular 5, I think. So what you're seeing here is what we call the vSphere client, and it is a hybrid application of AngularJS and Angular 5. And it looks simple on the surface, but this UI is huge. There's millions of lines of code and over 1,000 screens, and it's a very complex UI. It might look simple here, but doing a complete rewrite from Flex into HTML5 and JavaScript has taken a team of 100 engineers, over 100 engineers, over 2 years. And just on Monday, we had a huge party to celebrate us reaching what we call parity with the Flex client. So the Flex client was the old one. This is the new one, and they've finally reached the same level of functionality. So that's been a great milestone, and a lot of the UI work happened here in Sofia. So this is my SDDC, or my software-defined data center. It's completely empty. I haven't installed any VMs on it yet. It's partitioned into what we call resource pools. And the reason that we partitioned it into resource pools is because we as VMware have some stuff that we need to run on it. So the vCenter server application that this UI is actually presenting is running as a virtual machine inside this SDDC. So you can see we've got 2 resource pools. One is called the compute resource pool, and the other one is called the management resource pool. So the management resource pool is where we run all of our stack, and the compute resource pool is where a customer can install virtual machines. So let's do another virtual machine. I'm going to choose a local file, and I'm going to choose this one, Prince. All right, so it's pre-selected a directory for me where I have permission to deploy it. I have to choose the compute resource pool. It's going to validate the image for me now, so it's already being uploaded while this is happening. It's going to do a validation of the image, and hopefully in a second it will tell me everything's fine. Yep. I have to choose a place where I can put its disk, so the workload data store is where I'm going to put it. There's only one network at the moment, but because this is NSX based, I could go and create a number of different networks to allow me to manage a bunch of virtual machines, but the default is there's just one. I've got a summary page, and there's the deployment going. So you can see down here that we have a task that is running in the background to do this deployment. It shouldn't take too long. So this is uploading that image into the vSphere stack running in AWS in US US West. There we go, it's done. So this virtual machine, you might guess, is, let's power it on. Can anybody guess what this virtual machine is? I can, yeah, right, so I hit this problem before. So this server doesn't have a sound card, by the way, so I have to say no to the sound. So here we go. When I click on the virtual machine's console, it opens up in a new tab, and now I can play Prince of Persia. 60 minutes, wow, we don't have that much time. I won't bore you guys. Looks like it might be a little bit laggy as well. Anyway, that's what's going on there. It powered off for some reason. Anyway, so who's made a guess to how many regions we have in AWS? You can figure it out? Shall I show them the answer, Milan? Shall I show them the answer for the number of AWS regions? So, how do you want to do this?
Guess. 11.
So put up your hand and say, I want to answer, and I will pick out from the audience who's going to get to answer. And if you're right, the first person to guess correctly gets the ticket. Anybody? Java programmer? Yes. 4. Good guess. Too low. Yes, you're in the black. 12? Too many.
21.
21? No, that's too many. Sorry, did you say 7?
Yes.
That is the right answer. So the other cool UI that we've been working on is a dashboard that shows some metrics from our AWS deployments. So this dashboard was an intern project that happened last summer in the US, and it's an Angular app, and basically it's connected to our analytics system, which is getting data from the microservices that I was talking about before. So it's basically showing data that's about an hour old. Unfortunately, it's not real time, but you can see that we have 7 regions live and more to come. And on average, we have 3 hosts per organization. So usually customers these days don't have multiple SDDCs. We're working on supporting multiple SDDCs. So an organization is kind of representative of one SDDC. So customers are not deploying just one server, right? They're bringing up a cluster because they want to get the benefits of workload migration within the AWS SDDC as well, so that they can spread out the load. And 68 virtual machines is the average at the moment. So make sure you come up and grab the ticket. I don't know where Milan went, but you know who. Okay. All right. I think that was all I wanted to demo. So I guess, how am I going for time? We're pretty close, right? Does anybody have questions that I can answer? There's plenty of time for questions. Yeah, green shirt man.
I'm wondering, because you
mentioned that we have an opportunity to make virtual machine migration from on-premise to AWS Cloud. Is there an opportunity for something like fault-tolerant virtual machines, which is a feature of VMware Hyper-V?
Right. So the question was, can we do fault tolerance between an on-premise data center and AWS? I think, I don't actually know the answer. I see someone shaking their head over there. It doesn't seem like we support that today. I don't know whether that's on the roadmap. Do you know?
I think so. The biggest problem there is latency, actually.
Yeah. So with fault tolerance, right, we're talking about two virtual machines running instruction lockstep. So for those of you who don't know what fault tolerance is, it basically allows you to run two identical virtual machines on two different physical servers. And you would do this if you have a mission critical workload and you don't want any downtime if, for example, one of the servers fails. And in order to do this, the vSphere stack sends basically synchronization data between the two servers to make sure that the virtual machines are executing the same instructions and making the same storage requests. So the distance between the two data centers is significantly going to impact the performance. Anytime there's high latency between the two servers, fault tolerance is going to be problematic. So usually when customers are enabling fault tolerance, the two servers are close to each other and they have a very fast, low latency network connection. So I don't know how easy it's going to be for us to support fault tolerance without significantly impacting the performance. Good question though. Does someone else have any question? Yeah.
What's the minimum resource in terms of cost, CPU and RAM you can subscribe to?
For AWS?
For vSphere on AWS.
Right. So the interesting thing about deploying a vSphere stack is that in order to get fault tolerance again for storage, you need multiple servers. So the number at the moment is 3, which means in order to get VMware to support this SDDC, we require that you deploy at least 3 physical servers. We will allow you to deploy what we call a single host SDDC, but the support level and guarantees that we have for the data stored on that are much lower, and we actually limit the time that you can have that SDDC running to 30 days. So the single node deployment is really for testing and prototyping to figure out whether or not this is a thing that you actually want to commit to and bring up a bigger instance. The single node deployment, so cloud.vmware.com is our marketing site. And if we go to the VMware Cloud on AWS page, why didn't that go? There we go. So provision a single host SDDC. The single host SDDC is currently being charged out at $5.60 an hour. But as I said, you can only have it up for 30 days. So when you do that deployment, it's basically just for prototyping and testing, and you can bring it down, destroy it whenever you want, bring it back up when you want. You'll only be charged for the hours that you use. But there's other offers as well. So if you're interested in learning a little bit more about the costs and comparing it to AWS, for example, like if you were to bring up the same sort of compute capacity natively on AWS, I don't know what the cost comparison there is, but it's expensive. All right, we're talking about huge beefy servers, and VMware's managing the entire stack for you, doing all the support, huge amounts of storage. So it's not a small deployment, right? It's certainly, if you want to play around, right, $5.60, if you just want to play around for an hour, nothing too bad. So it's only when you really want to do a production deployment. And so we also offer term contract discounts. So if you decide that you do want to do a deployment, and obviously if you're going to invest and move workloads there, right? Depending on the size of the data, you probably don't want to move them back and forth every hour. So a lot of the initial customers are subscribing to 1-year contracts for 3 or 4 host SDDCs. We also have a 3-year contract, and so depending on how long you subscribe for, it brings the cost down significantly, right? The longer term contracts are significantly cheaper than this $5.60 an hour. Any other questions? Yeah.
Do you have a free tier like the other cloud providers?
No, unfortunately,
Not yet.
because of the reasons I just described, we're talking about a really beefy server here, right? It's expensive just to have those things sitting there. So that SDDC that I deployed, somebody's going to email me tomorrow and say, hey, do you need that? Because it's costing us thousands of dollars every hour you have it running. So unfortunately, we don't have a free tier at the moment, but it's possible. We have offered customers promotional credits to get them into the system and try it out. But the single host deployment at $5.60 an hour is our way of sort of offering it to, I mean, you can pay for this with a credit card, right? But if you're going to subscribe to a term contract for 3 hosts for 3 years, we're talking probably tens of thousands of dollars, right? Which you're not going to stick on a credit card. So anyway, we're really trying to offer the ability to test this out, not only just for existing customers, but for people who haven't played around with the vSphere stack before and are interested in trying it out. Just on the topic of free tier, ESXi itself, we offer a free version. You can go to VMware.com and download ESXi. If you've got VirtualBox or Fusion or Workstation or KVM, you can bring up ESXi in a virtual machine and play around with it. In fact, that's how I built the host client UI, right? I was on a laptop with Fusion, installed ESX, developed away. I could work on a plane without an internet connection because I had ESX running in Fusion, which is a really nice way for a UI engineer to work. My ideal working environment is where I don't have to run a 8 gigabyte Kubernetes cluster on my laptop, right? I can connect to a live running instance, or I can bring up a virtual machine and run stuff in there. Any other questions? Yes.
In the context of software as a service, how do you consolidate the microservice approach with the end-user client apps? Does it extend beyond the APIs into the application?
Right, so the question was, with the microservice architecture that I was talking about before, with the console UIs specifically, so that's the VMware Cloud on AWS console. How do we build the UI, right? Because we've got maybe 10 different microservices in the back end. They're in their own containers. They've got their own APIs. It depends on the console, right? The architecture is slightly different for VMC than it is for the cloud console. And in the case of VMC, we actually will make API calls in the UI. Like it's a single monolithic UI, basically. We haven't yet embarked on this idea of micro front ends, if you're familiar with the concept. It's something that I'm investigating right now, because there are problems with the monolithic UI. And so what we have is a monolith, and the different parts of the UI make API calls into the different microservices. They use the same authentication though, so it's not like we have to create a new session token for each different microservice. It all goes through the same API interceptor, and the authentication is handled that way. The console UI, which was console.cloud.vmware.com, is slightly different. We actually have a Java backend that serves the UI and presents a stable UI that the UI is coupled to. But again, this is a monolith UI. There's no micro frontends in there. But one of the projects that I've been involved in is, as a UI engineer, we want our UIs to look the same, right? And you'll notice that the VMC console and the main cloud console look very similar. And in fact, they're sharing a common navigation component to get the customer experience to be familiar across the two UIs. So this help panel that I've recently built, this is a new feature, and we call it in-product help experience. This component was built as a custom element using Angular elements. So this is a new feature of Angular 6. And basically that allows us to deliver the help panel experience as a package. Instead of giving every service UI the code for the help panel and having them build it into their UI, we can deliver the help panel as a sort of package at runtime. So parts of the system are evolving to a micro front-end architecture. It's obviously a fairly new way to build UIs, and we're sort of in the initial phases of the investigation for how we can build larger chunks of the UI that way. But it's a really interesting direction to take UI in. And
is state managed client side or
is what, sorry?
state?
State?
Yeah.
Yeah, that's another good question. So yes and no. The VMware Cloud on AWS console has two ways of getting data into the UI. Firstly, there's a REST API, right? Backend teams are quite happy building REST APIs. On the other hand, we want our UI to be as live as possible. So when events happen in the backend, I want my UI to react immediately. I don't want to poll the backend and say, hey, has something happened? Has something happened? That's inefficient as well. So the VMC UI actually has a WebSocket connection, and it's connected to Spring. We have a standard protocol on the WebSocket called Stomp, which is a message-oriented protocol, and it sends JSON packets, basically. And in the UI, the packets are delivered on channels, and we have a ReactiveX observable that represents the channel, and we just subscribe to that observable, and when the backend sends us a notification, our observable fires, and we can do something in the UI. So in terms of state management, those messages are not stored in a store in the UI. Other things are. So for example, the SDDC data structures that represent those three SDDCs, those are cached in the UI, and we get notifications down our WebSocket when the state of an SDDC changes and we update our cache. So when I navigate away and come back to this tab, we're not making API calls constantly to retrieve the same data. We make the API call once when the UI loads, we put it in the store, and then we watch the WebSocket notifications come in to invalidate our cache, basically.
In the event of a microservice outage, is there some kind of fallback scenario in the UI?
So this is an aspect of the system that we're only just sort of getting to. The microservices in the backend are redundant. There's multiple instances of them running, and they are redundant and load balanced. The health of the system is monitored by a Marathon DCOS data center management system. So if the health of a particular instance of backend shows that there's a problem, it's going to stop routing traffic there. And those are stateless microservices. So if one goes down, the load balancer just stops sending requests there, and we get a blaring red alert that says, there's a problem. And in fact, with the Kubernetes deployment that I was talking about, it's monitoring the health and will actually restart the microservice. We actually had a production issue, sorry, not a production issue, a staging issue today in our staging environment, which actually has the same SLA as our production environment, where one of the microservices was getting out of memory and restarting. And so this actually impacted our users. They noticed that the system became unresponsive while the instances were rebooting. And because it was an issue that impacted all of them, right, they all started rebooting and the system would come up and go down and come up and go down. So, anyone else? Seems like we're out of questions. So, shall we do the draw for the ticket? Did you hand out the tickets yet or not? 15. Really, is that all? I guess UI engineers don't care about Java, so. All right.
One more question.
Yeah.
How much RAM has your virtual machine with Windows and Mac?
How much RAM does my virtual machine?
To run successfully Windows and Internet Explorer.
I didn't actually have to pick the amount of memory that thing got, but let's take a look. So go to the settings. How much did Microsoft decide this virtual machine needed? 1 gigabyte of memory. That's it. And that was the recommended amount. So it's an interesting question because when you pick a guest operating system in Fusion or any other system, we have a list of supported guests and guest versions, and we have recommendations for how much memory those guests need. So if I was to go and pick Windows 10 as the guest I'm going to deploy, Fusion is going to recommend that it needs at least 2 gigabytes of memory or something to that effect. So when I take a template and deploy that, which is what I did with this 8.1 machine, the template has the memory pre-configured, and so Microsoft decided that this one needed 1 gig of RAM. Yeah. I mean, we're going to be around for I guess another 40 minutes or so, right? So if anybody has any other questions, I'm happy to answer them in person or whatever. We have a bunch of VMware engineers here as well, so they'll be happy to answer questions. So we were going to do the draw for the tickets. So let's do math.random times 15 and math.round. We ready? Oh, it says it's 9 already. I didn't even ask it yet. 2. Who got number 2? Anybody? No. What? How did that happen? Someone left, you think? So I need to ask Chrome to do another random number generation? All right.
I think that I have that ticket.
You think? You better check it before I do this again. Last chance.
Yeah.
You are number 2. Well, there you go. Lucky I didn't press return yet. Delete. Congrats. We'll get you the ticket. Cool. All right. Well, I think there's some pizza and Coke and stuff, right? I'm hungry. Hungry. All right. Thanks, everybody, for coming. If you're interested in joining us on this grand expedition to the cloud, we have really interesting challenges to solve. And I like visiting Sofia. This is my first time here, but I would love to come back and see you all again. All right. Where's the pizza? Downstairs, right? Yeah. Thank you.